Definitely something that's next on my list.
This broadcast is made possible by the Capricorn Group. This lesson is provided by Eduvision with the support of sponsors.
Right, grade 11s. We are busy with the electron distribution around the nucleus of an element. And in the last period, I said to you, we can divide up the periodic table into so-called S block elements, P block elements, D, well, it's actually a small letter D, D block, and F block elements. Okay. We have to have a look at the electron distribution. We get S block, P, D, F, and F block elements. Now, if you remember, we said S block elements. These elements, group 1 and 2, what does it mean if they're an S block element? They have electrons in the S sublevel, their outer shell electrons. The P block has got electrons in the P sublevel. The D block have outer shell electrons in the D block and the F block elements. All right, now remember we said the pattern of 2, 8, 8 electrons is not entirely true. It works for the first 20 elements. The next model that we use is slightly more complicated. Remember I said, if we could open up the shells, if I could cut them open, then I have 1 shell, 2 shells, 3, etc. And I said to you, in the first shell, how many electrons go in? 2. And we say there's space for 2 electrons. They have opposite spin, so they attract, they pair off. The second shell, we said, this is the S sublevel, it has a single S sublevel and 3 P sublevels. It's got place for 8 electrons. It goes 1, 2, 3. Each one will go 1 into a subshell, and then they will start pairing off. All right? Then we said the third energy level has got an S, 3 Ps, and 5 D sublevels. So it's S, P, D. And once again, the electrons as they are, it just carries on. It first goes there and there, then it goes there, then it will pair off. And then we said what will happen. It's going to jump to the 4S sublevel because it's easier to fill that S sublevel than what it is to fill those. All right. And then it will come back and it will fill them, one each, and then it'll pair off, etc. Okay. It gets quite complicated, but there's a pattern that one can draw to figure out the order. Yeah. Yes. All right. Now, the pattern that you can draw to help you remember how the electrons go in, we can go and write it as follows. Where is my little pattern? Okay. 1S, 2S, 2P, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f. Okay, now the electrons go as follows. They fill first the s sublevel. All right? Then the next S sublevel. Okay, have a look. 1, 2, 3, 4. Are you with me? Okay. Then 2p, 3s. So here are my 2p, and there's my 3s. So there, then there, and there. Okay, now here is the 3p, the 5ds, and the 4s. Okay, 3, 2, 1. So now it goes 3p, 4s. So it is going to go 3p, pairing off. It jumps 4s. It comes back 3d. Yes, 4p, 5s, and they won't ask further than that. But it's just easy. Once you've drawn it, it's easy to figure it. No, they usually just go up until it jumps, and then it comes back to that. And they don't usually go any further than that. Now, when we're going to have a look at the SPD notation, there are two exceptions to this order. Now, your syllabus does not specifically say you must know those two exceptions, but they also don't say it. They say in general, you must be able to do the SPD notation. So now the two exceptions are chromium and copper. I just want to see, maybe I can, I want to make the whole thing smaller. Not going to work. Okay. We have chromium and we have copper. Now, chromium has got 24 protons, and copper has got 29 protons. Okay, so what is going to happen is that if we go and have a look at let's do the distribution of chromium first. I'll draw in my cells. 1s, 2s, 2p, 3s, pd, 4s. Okay, so we have that, 1, 2, 3. We have that, 1, 2, 3, 1, 2, 3, 4, 5. We have one there. Okay, I'm not going to draw the others. Okay, so chromium has got 24 electrons. Remember, they fill the lowest ones first. And then before they pair off, they go 1, 1, 1 until sublevel is full, and then they pair off. So we go 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, 19, 20, 21, 22, 23, 24. They are each going to take 1, if I remember correctly. Yes. No. That's where the exception comes in. Normally, it would now go up there and fill up that one. It doesn't. It doesn't. There must be 24. We've got 10, 18 altogether. It goes 19, 20, 21, 22, 23, 24. That's the exception on chromium. All right? Yes, it doesn't want to do that. Because it's got to do with the energies involved. Okay, so just accept it at that. So make a note of chromium when you go and learn. All right, that one. And copper is going to go as follows. We also have 1 P, S, P, D, and S. Okay, now copper has got 29. Now the first ones that go in goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, it will go. We've got 10, 18. It goes 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Yeah. Okay. It's only chromium and copper that do this. No, it doesn't. It will fill up the S sublevel. Chromium and copper. Yes. No, then they will first go up to that one, and then they will come and fill up that one. Yes. Yes. And then it goes to the P. All right. No, no, no. Say again? I've just said they all jump to S except chromium and copper. So make a note of the exception. Just write a little note in there in your books. Then you should be all right with that. Okay, in your textbooks, okay, the electronic structure, they explain it there, but it's not that complicated once you've got that. It's only chromium and copper, which are the exceptions. The chances of them asking it is very, very slight. It's just sometimes, you know, they do ask stuff like that, so I like doing it. If it confuses you, just ignore it, because it'll be 1 or 2 marks. Okay, now, from this, they go and say to you, give the SPD notation of, for example, chromium. Okay? There. Give the SPD notation of chromium. So now you go and say to them, we have chromium, and the 1s subshell has 2 electrons. Yes. 2s subshell has 2 electrons. The 2p subshell has 6 electrons. The 3s has 2. The 3p has 6. There. The 3d has got 5. The 4s has got 1. And there is the SPD notation of an element. No, for this, maybe 2 marks. All right? It's not all that difficult. No, it's not that difficult. It's just something new. Yeah. If I said to you, give the SPD notation of chlorine, then we will go 1, 2, it's got 17 electrons, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So for chlorine, the SPD is going to be 1s2, 2s2, 2p, 6, 3s2, 3p. We've got 2, 4, 5. There we go. No. All right. Yes, yes, you can do it in the margin that there will be space. Okay, now I go and say to you, give me the SPD notation of a chloride ion. Gains an electron. Okay. Or if they said calcium, which loses 2 electrons. Let's do calcium. Calcium, 2 plus. Let's first do just ordinary calcium. Calcium has got 20 electrons. So, are you with me? Okay. So, 1, 2, we've got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Not so? Okay. So what, for calcium, the metal, it is going to be 1s2, 2s2, 2p, 6, 3s2, 3p, 6, 4s2. But the calcium ion, okay, because it loses its outer shell electrons. Koros? Yeah. No. It jumps. That's just what you have to go and learn. From the 3p sublevel, it jumps to the S and then it comes back to the 5d sublevels. No, it doesn't. It's got to do with the shielding of the shells and the pairing off with a number of electrons, etc. Okay. They won't do it. They won't ask it of copper because it involves something called hybridization that you don't do at all. Okay. No. No. Yeah, 4 is 1. Yes. No, 10. No. Don't know whose book you've got. Look at the name. Should tell you everything. It's just fine. Just correct it. Can we do what? Argon will have a filled outer shell. Okay, I'm going to do it on this one. I'm just going to use a different color. I'll use black. How many electrons does argon have? 18. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Why does argon not want to make chemical bonds? It's got a filled outer shell. Yes. The covalent bond, they share electrons. What happens is two of these orbitals, I want that one there. Okay. One of them overlaps with another one, and they share the electrons in the overlap. Okay. It's quite complicated. Yes. 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 Then there will be one open. 18, no, sorry. It will fill up till there because that's 18, and then it will go there, 19. Okay. Yes. Yeah. Mm. Mm. No, but it doesn't matter. It doesn't have to be 8. Because the moment you go beyond the first 20 elements, it'll start filling up here. But what happens is, let's take a new board. If I go there, we go. There's 1, 2, 3, 1, 3, 5. Okay, let's say it's going there. We go there. We go there. There we go, there, and then we go there, and then we go there. Very often, now this is a D block element. Can you see that? Why? Because I've got outer shell or the last electrons going to the D block element. What's one of the properties of the D block elements, the transition metals, they have more than one oxidation state. Now, oxidation state means the number of electrons they can lose or gain. In other words, the number of bonding places it comes down to. Sometimes copper is +1, +2. It can even be +3. Iron can be +2 or +3. But why? Where does this come from? Well, what happens is the hybridization. It makes 6 similar orbits within one sublevel, and then I will have 4 bonding places, or I can have 2 bonding places. Or if I only had 1 there, I might have 3 bonding places. And sometimes it even does other stuff. Do you understand? So the number of bonding places are not fixed on the transition metals. It can differ, but because of the D block that is filled. Yes. For the first 20 elements. Well, technically, it can become more, yes. All right. The third shell can maximum contain, that's 10 plus 8 is 18. The fourth shell has got 7F, so it's 14 plus 10 plus 8. So it can have, 32 electrons. Okay, but it becomes too complicated. That's why in grade 8, 9, 10, we just worked with the first 288. All right. Okay, so, yes, I want to carry on. Okay, now, the next thing that we must have a look at is the bonds that form. Now, what type of chemical bonds do we get? Covalent, ionic, metallic. We did them in grade 10. What is a covalent bond? No. Sharing of outer shell electrons. In other words, something like carbon dioxide is covalent because we have carbon and we have 2 oxygens. Okay, there's an oxygen and there's an oxygen. Here we have carbon. Carbon has how many outer shell electrons? It's got 4. It's looking for 4. So how many must it share? 4. Oxygen has got how many outer shell electrons? 6. It's looking for 2, so it must share 2. So 1, 2, but it's got how many electrons? 6 altogether. So 1, 2, 3, 4, 5, 6. That oxygen does the same. All right. What does the carbon do? Well, it must share 4, and it's going to share them equally. So carbon is going to go 1, 2, 3, 4. And there we have carbon dioxide, which is molecular, because it is a sharing of electrons between non-metals. You have a double period, eh? Okay. Look, I won't carry on the full double period, but I do want to carry on a little bit. So, molecular substance share electrons between non-metals. Now, what are the properties of molecular substances? Low melting and boiling point. Why? What forces do we have between molecules? Weak van der Waals forces. So low melting and boiling point because they have weak forces holding the particles together. If the forces are weak, it will be soft solids, but usually they are liquids or gases. Are there any charged particles? Free to move? No, so it does not conduct electricity. No, pure water does not conduct. The only exception there is graphite, which does. But that's got to do with the... No, doesn't conduct. All right. The dissolved salts in it. It's a very good solvent. Okay? And we add chlorine to it and just the mineral salts that dissolve, because any ionic solution will conduct, because you have charges that can move. All right. What is an ionic bond? A metal bonded onto a non-metal. What is the product called? A salt. Okay? But how do we get the metal and the non-metal to stick onto each other? The metal loses electrons, the non-metal gains the electrons. If an atom loses electrons, it becomes positive. If an atom gains electrons, it becomes negative. What force do we have between positive and negative? Yes, strong Coulomb forces. So, what will the properties of a salt be? High melting and boiling point. Yes, good. This is of electricity. Hard, brittle, solid. Yes, electrostatic would also be fine. Strong Coulomb forces or electrostatic forces. Are you with me? All right. How do we show the bonding in ionic substances? Remember, with the molecular substances, it's a sharing of electrons, so the outer shells overlap, and we only show the outer shell electrons. But with ionic substances, we have to show the bonding slightly different. So if I said, no, don't take copper sulfate, because the sulfate ion, the structure is complicated. They won't ask that of you. But copper chloride I can take. Okay? So copper chloride, we are going to have copper will have 2 outer shell electrons. Yes, they won't ask this one either, because it's a transition metal. Do aluminium chloride. Oops, 3. Okay, so aluminium in its outer shell has got, well, in a moment, and let's do chlorines. 3 of them, 1, 2, 3 of them. Each chlorine has got how many electrons? 7. Yes, 7. I'm going to do it now. 1, 2, 3, 4, 5, 6, 7. Okay, now, aluminium has got 1. And then I just want to 2, 3. Okay, so what is going to happen is you must show that aluminium is going to, come on, do that, that, and that. So you have to show aluminium is going to lose its electrons to the chlorine. The moment aluminium does that, you show it is plus 3, and the chloride becomes -1, -1. There is the ionic bond. All right. Be careful. Don't show the electron there and there. Then it's wrong, because then you've got extra electrons. They want you to empty the shell and put it in on the formation of the negative ion. Yes. In the end, what do we write? We say aluminium 3 plus 3 chlorides give me aluminium chloride. All right. Any questions on this? Trinitrotoluene or something like that. Ooh. It's probably molecular because it's a liquid. Probably. Yeah, trinitrotoluene. Something like that. I'm not exactly sure. Okay. Yeah. Why do you have? Because the formula tells me I have 1 aluminium and 3 chlorines. Okay. All right. People remember that we can get double and triple bonds. For example, the oxygen molecule. Oxygen has got 6 electrons in its outer shell it's looking for. 2. So each oxygen will share 2 of its original 6 electrons. The other one does the same. So here we find we have a double bond. In comparison to something like hydrogen, with 1 electron each, which one would be more reactive?